26,000 light years from Earth. Shrouded in cosmic dust and gas is a mysterious region of space, the center of the Milky Way.
The center of the Milky Way galaxy is one of the strangest, most exotic, and violent places in our galaxy.
Gas streaming everywhere, radiation blasting out, stars moving willy-nilly.
And at the very heart is the mysterious black hole, 4 million times the mass of the sun.
Now, we're exploring the center of the Milky Way like never before, uncovering powerful forces that affect us all.
Everything that happens at the center of the Milky Way galaxy really is connected to what's going on in the rest of the Milky Way.
Understanding the center of our galaxy unlocks secrets of our past, present, and future. March 2019. We focus the XMM Newton Space Telescope on a region of space around Sagittarius A star, the supermassive black hole at the heart of our galaxy. We spot two huge columns of gas glowing in X-ray light. The columns seem to be coming from Sagittarius A star.
We see giant fountains of gas extending outward from the central region, as though it's like a wind or a giant expulsion event.
The fountains of gas extend 500 light years above and below the supermassive black hole. That's over 1 million times the distance from the Sun to Neptune.
It looks like this material is actually leaving the vicinity of the black hole, like it's burping out these giant hot X-ray chimneys.
So why is Sagittarius A star burping out hot gas?
Typically around a black hole, you have an accretion disk funneling material into the black hole, but all of it doesn't end up in the black hole.
There is a little bit of gas falling onto it right now, even as I'm speaking, right? As gas falls toward the supermassive black hole, it becomes superheated, it liberates an enormous amount of energy, and that energy has to go somewhere.
As gas spirals towards the black hole, some of the material accelerates to near the speed of light. It blasts out from the accretion disk, creating chimneys of superheated gas that seem to connect to two of the largest structures in the galaxy, the Milky Way's Fermi bubbles.
A few years ago, we noticed that in fact there are these giant bubbles coming out of the very heart of the Milky Way galaxy. In each direction, there's a bubble 25,000 light years long.
But the gas-filled bubbles dwarf the chimneys of superheated gas. Scientists wonder if another, more powerful force blew the bubbles.
So what could have created all of this superheated gas that actually blew these tremendously large bubbles?
Supermassive black holes in other galaxies might offer clues.
Black holes at the centers of galaxies go through different phases, so they can be either active or they can be calm. Sometimes black holes at the centers of galaxies go through an active phase. And when that happens, the black hole is actively feeding on material around it, which means it's growing, and it also gives off huge jets of radiation.
Calm supermassive black holes release a trickle of hot gas. But when lots of material falls on them, they can shoot out jets up to millions of light years long.
At the current time, Sagittarius A star is what we call quiescent. It's quiet. There is some material swirling around it, but really not very much. But we don't think that's always been the case. The centers of galaxies are busy places. There are stars there, there's gas there, there's dust there, and sometimes these things fall into that black hole.
6 million years ago, Sagittarius A star may have had a feeding frenzy, eating too much and blasting out the remains in huge jets.
Those jets plow through the galaxy initially at near the speed of light. And as they do so, they can wreak havoc or sculpt the evolution of the galaxy that they're propagating through.
Sagittarius A star's jets blasted gas out of the galaxy, creating the scars we see as the Fermi bubbles.
Now, whatever caused those jets seems to have turned off. It's not happening anymore, and we're seeing sort of the leftovers of them. But this is clearly a sign that sometime in the past few million years, the black hole in the center of our galaxy, Sagittarius A star, was actively feeding on material around it. Material was falling into it and blasting out this stuff.
The jets left destruction in their wake. They may have also affected the growth of our entire galaxy.
These structures at the center of our galaxy are important because they can either shut off star formation or they can trigger star formation.
As those jets propagate through the galaxy, they pile up gas. And that gas can be then triggered into star formation. But these jets can also impart so much heat or energy feedback into the environment that they prevent star formation. So black holes in many ways conduct an orchestra, instructing or dictating when stars can and cannot form.
In the center of the Milky Way, star formation rates seem low. The jets could be responsible. But in 2017, the ALMA telescope discovered the change is coming.
So ALMA's actually been able to peer into the heart of our galaxy and see that near all this destruction, there might actually be a new generation of stars forming.
Today, our calm, supermassive black hole could be helping star formation in the core. But the Fermi bubbles could be evidence of a time when Sagittarius A star shut down star formation. Could the supermassive black hole roar back to life in the future?
Sag A star could roar back to life by just dumping some gas onto it. And there's a lot of gas at the center of our galaxy, and it could wander into the proximity of Sagittarius A star and ultimately fall onto the event horizon. And that would light it up.
If Sagittarius A star eats enough gas, it could shut down star formation in the galaxy for millions of years. It could also give off X-rays and gamma rays that may hit the Earth.
Thankfully, our central supermassive black hole is pretty quiet, and massive feeding events, massive energy events are very, very rare. We don't necessarily have much to worry about.
Sagittarius A star has reshaped our galaxy. If we want to survive in the universe, we need to know more about this monster black hole. The Event Horizon Telescope is on a mission to do just that. Question is, can it succeed? The center of the Milky Way is home to a supermassive black hole, Sagittarius A star. At least, we think it is. We've never seen the supermassive black hole directly, but we have seen stars racing around the core.
The speeds of the stars zipping around the center of our Milky Way galaxy indicate that there's something very massive and very compact there. Indeed, 4 million times as massive as our sun in a volume smaller than that of our solar system. It's gotta be a black hole, basically.
By measuring the orbits of stars in our galaxy's center, we estimate that Sagittarius A star is over 100 times wider than our sun. But despite its size, the black hole is hidden.
One of the immediate challenges of actually observing black holes is the fact that they don't emit light, and so you can't see them, right? So we've never actually seen a black hole, we've only seen the stuff around a black hole, or we have seen the effects that that black hole imparts on its ambient surroundings.
That's where the Event Horizon Telescope came in. Its goal was to photograph Sagittarius A star. Not the black hole itself, but its shadow.
Around it is this gas that is moving around the black hole that's superheated to millions of degrees, and what the Event Horizon Telescope is trying to see is the shadow of a black hole.
Light from the hot gas around Sagittarius A star frames the giant shadow. It could be up to 93 million miles across. Problem is, Sagittarius A star is so far away that the supermassive black hole is still incredibly hard to see.
Sagittarius A star is big, but it's 26,000 light years away. You know, a single light year is 6 trillion miles. So this is a long, long walk. And even though it's big, that distance shrinks its apparent size to just a tiny little dot on the sky.
To see the tiny dot, we need a telescope the size of the Earth.
How do you possibly do that? You can't build that telescope, right? Well, there's a trick. You actually get a few different telescopes and you spread them out over the surface of the Earth.
And when we add all of these sites together, we wind up being able to take an image of something that is really, really impossibly small.
To gather enough light to see a target this small, the team take long exposure images of Sagittarius A star's shadow. But there's a problem. The accretion disk moves too much for us to capture a clear image.
When you're taking a long exposure of a person, right, you need them to be really, really still, right? Because if they're moving around a lot, they're gonna blur the image out. And that kind of thing is happening when we observe Sagittarius A star, because it is unwilling to sit still for us. It is booming and banging and flashing on the timescale of literally hours.
As glowing material orbits the black hole at 30% the speed of light, Sagittarius A star's shadow blurs. Future developments may allow us to see Sagittarius A star clearly. For now, we can't capture an accurate image of our galaxy's supermassive black hole. But the hunt to see a supermassive black hole wasn't over. The Event Horizon Telescope turned to another galaxy 54 million light years away, M87.
M87 is an absolute beast of a galaxy. It's a so-called brightest cluster galaxy. These are among the largest galaxies in the universe.
And M87 is home to another supermassive black hole, the giant M87 star.
M87 star is so massive that the gravitational region that's interesting is actually easier to image than the black hole in our own galaxy.
M87 star is over 1,000 times more massive than Sagittarius A star and has a far larger accretion disk. When photographing a black hole, size matters because big accretion disks project more stable light, so images of them don't blur as much. In April of 2019, the Event Horizon team unveiled their image.
We have seen what we thought was unseeable. We have seen and taken a picture of a black hole.
I've been working on this project for almost 6 years now, and so this is something we've been looking forward to for a really long time.
Capturing this image took decades of work by hundreds of scientists all over the world.
I was really stunned. Suddenly, when you say that's the real thing, that's amazing. It really affected me. This is something 6.5 billion times the mass of the sun, 55 million light years away, and we're looking at it?
So when you look at the image, it's totally fine. You're totally forgiven for thinking, it looks a little blurry. But I cannot reiterate enough how profound this image actually is. We are seeing just a hair's width away from a discontinuity in the fabric of space-time itself. Actually seeing so close to an actual event horizon, a discontinuity in the fabric of space-time, never seemed possible.
This image of the heart of a distant galaxy helps us understand supermassive black holes like never before.
When we observe supermassive black holes in other galaxies, including the one in M87, we're able to learn more about the big picture of how these massive black holes form and evolve over time. And that in turn helps us understand how our Milky Way galaxy and its supermassive black hole has formed.
By studying, not just making images of black holes, but making videos of black holes and seeing as that gas is spinning around it, we can try to map around a black hole more precisely and learn about its dynamics.
An image of Sagittarius A star remains out of reach, but in 2018, it shows a deadly side to its character. The supermassive black hole's accretion disk releases huge, powerful flares, and they could be pointed right at us. In 2018, astronomers were studying a special star orbiting our galaxy's supermassive black hole. The star passes close to Sagittarius A star every 16 years. It's called S2, and by studying this star's flyby, we hope to learn more about Sagittarius A star.
We think that S2 may be the very closest star to the supermassive black hole in the center of our galaxy. At closest approach to Sag A star, S2 comes within 17 light hours or so of the surface.
The supermassive black hole's powerful gravity accelerates the star to 17 million miles an hour. That's fast enough to travel from New York to LA in half a second. But it's not the star's speed that excites scientists.
This is a great star because it's on an elliptical orbit that takes it fairly far from the black hole, but every few years it passes right above the supermassive black hole.
As we tracked S2's swing around Sagittarius A star, we detected powerful bursts of infrared light coming from the direction of the supermassive black hole.
There's a blob of gas that is orbiting very close to the black hole, and it was flaring as it went around. There were 3 separate flares of light that they were able to detect.
The flares didn't come directly from the supermassive black hole. They came from the material around it.
The flares that were discovered are thought to originate from magnetic storms in this very, very hot turbulent gas around the black hole.
The extreme heat in the accretion disk strips electrons from atoms of gas. The stripped electrons and hot gas form a plasma, which creates powerful magnetic fields when accelerated to high speeds.
Because some supermassive black holes have these superheated, rapidly spinning vortices of gas swirling around them, you get these very, very powerful, very tightly wound magnetic fields.
And there's energy stored in that magnetic field. It's like a bunch of piano wires all tangled up. And if these things interact with each other, they can snap. And when they snap, that energy is released.
You'll get this enormous release of energy as these coils of magnetic fields effectively snap. And when they do so, just like on the surface of our sun, they release an enormous flare of gas.
These powerful flares can be millions of miles wide and come packed with superheated gas and plasma. Solar flares release as much energy as 10 million volcanic explosions. Flares from Sagittarius A star's accretion disk are like millions of solar flares, all going off at once.
It's kind of like comparing a nuclear weapon to a firecracker.
Sagittarius A star's flares release intense blasts of radiation. But by watching the flares from Earth, we can learn about the orientation of the supermassive black hole's accretion disk.
This gas that's in this accretion disk around the black hole is like a friendly helper shining a flashlight back toward Earth. And we can watch the orbit of these flashlights and help understand the orientation of gas that swirls around the black hole. We think we're getting a bird's eye view of it and looking down the barrel or looking at the accretion disk basically face on.
That means that any material that gets blasted away from the black hole could be aimed right at us.
Should we be worried about the flares reaching Earth?
It sounds worrisome, this blob of gas emitting these huge flares of light. But you gotta realize, this is 26,000 light years away. That is a long way. It took an extremely sensitive detector on one of the largest telescopes on Earth to be able to see this at all.
Earth is safe, for now. But the more we learn about the galaxy's center, the more terrifying it becomes.
We know of Sagittarius A star, the central supermassive black hole, but now we're beginning to suspect that it might not be alone.
A dangerous swarm of black holes could be racing around the center of the Milky Way. Thousands more may be hiding from sight. The supermassive black hole, Sagittarius A star, dominates the center of the Milky Way, affecting star formation and carving out vast gas bubbles in space. But Sagittarius A star might not be the only black hole in town, or even the most dangerous.
We've known for a long time that there's a supermassive black hole in the very heart of our galaxy, but there may be an angry swarm of smaller black holes buzzing all around it.
In April of 2018, astronomers led by Columbia University revealed the results of a hunting mission in the center of the galaxy. They'd used 12 years of Chandra Observatory data to seek out stellar mass black holes.
Black holes that are made from the death of stars from supernova explosions are called stellar mass black holes. And these are made from stars that were many times the mass of the sun.
Finding stellar mass black holes is tough. Light can't escape a black hole's gravity, so we can't see them directly. And stellar mass black holes are only tens of miles wide, making them almost impossible to detect. So astronomers look for a special type of stellar mass black hole.
One of the ways that we look for stellar mass black holes is that they often are vampires eating a companion star.
These vampires are part of a binary pair, a stellar mass black hole in orbit with a living star, the black hole feasting on its partner.
That black hole is like a very, very deadly parasite for that star. It is ripping mass off the surface of that star, and that matter is raining down toward the black hole itself.
And that material lights up. So this allows us to hunt for black holes, not through taking pictures of black holes directly, but through seeing the material falling to its doom.
Problem is, gas and dust spread throughout the galaxy stops visible light from the binary pair reaching Earth. But the binary pair release another type of light that passes through the gas and dust more easily: X-rays.
The system itself is emitting X-rays, so they're called X-ray binaries. So these are useful because the X-ray emission can be very powerful and can be potentially seen from the Earth, even though the binary is very far away, say at the galactic center.
The glowing disks of material in X-ray binary systems are almost 1 million times smaller than the accretion disk surrounding Sagittarius A star. Too small for us to see the material swirling around them in detail. So, we see the X-ray binaries as pinpricks of X-ray light. Astronomers detect 12 of these X-ray binaries in a small, 3 light-year wide patch of space at the galactic center.
And that means that there could be a much larger collection of these relatively tiny stellar mass black holes in the heart of our galaxy. If black holes form the way we think they do, there very likely may be swarms of black holes racing around Sagittarius A star.
But X-ray binaries that are powerful enough for us to detect are incredibly rare. So, we estimate that for the dozen X-ray binaries discovered, there could be up to 1,000 more. In total, there could be 20,000 stellar mass black holes in this 3 light-year region of space. Why are these black holes swarming in the galaxy's center? It appears they've migrated from the rest of the Milky Way.
Through a process called dynamical friction, black holes can actually sink to the centers of galaxies very, very rapidly, like dropping a stone into a pond. What that means is that an errant, wandering black hole might eventually find its way toward the center of our own galaxy, where Sagittarius A star resides.
As stellar mass black holes orbit the galaxy, they interact gravitationally with stars and clouds of gas and dust. These interactions push the black holes towards the center of the galaxy, where the black holes swarm. A swarm of stellar mass black holes sounds deadly, but it may not be the most lethal thing in the center of the Milky Way.
A surprising observation indicates that there is a lot of antimatter in the center of our galaxy.
And when antimatter meets matter, the results are explosive. In 2017, astronomers tried to solve a decades-old cosmic mystery. Unexplained high-energy radiation streaming through our galaxy. At first, we didn't know where it was from. But we discovered it was gamma radiation coming from somewhere in the center of the Milky Way.
The question is, what's making these gamma rays? That's hard to do. It's not like you can rub your hands together and generate gamma rays.
When we took a closer look at the gamma rays, we discovered the signature of the most explosive substance in the universe, antimatter.
Antimatter is like normal matter, but with opposite charge. That's it. It's matter's evil twin.
When evil twin meets good twin, it is not a happy reunion.
Antimatter is scary. It's not like you want to have some in your kitchen. This stuff is very, very explosive if you want to think of it that way. If it touches normal matter, it releases a huge amount of energy.
When matter and antimatter combine, they annihilate each other and transform into high-energy radiation, just like the gamma rays seen streaming out of the center of the Milky Way. We see antimatter throughout the galaxy, but strangely, the galactic center seemed to have 40% more antimatter than anywhere else.
Right now, in the heart of our galaxy, we actually observe fountains of antimatter that are producing 10 trillion tons of antimatter every second.
One of the big questions that we've wondered about for a very long time is, what's the origin of this stuff?
Initially, there were several suspects.
One possible source of antimatter is the central supermassive black hole, Sagittarius A star. Matter can be swirling around this, and it can have such high energy that it can create antimatter.
But the antimatter isn't coming from a single point. It's spread across thousands of light years of space. So Sagittarius A star can't be the source of the gamma ray stream. Another suspect was dark matter.
One of the biggest mysteries in the universe right now is dark matter. We know that the majority of mass in the universe is not in the same form that we are. It's not made of atoms. But whatever sort of particle it is or may be, if these things collide, they can produce antimatter. And that will produce the gamma rays. So it's possible that as we look into the heart of the galaxy and see these extra gamma rays, that's the signal that dark matter is there.
But the gamma ray stream we detected is too weak to have been created by dark matter. Then, we had a breakthrough. We discovered that a special metal called titanium-44 could be responsible for the gamma ray stream.
Titanium-44 is a highly radioactive element. That means that it wants to decay into other types of nuclei.
When titanium-44 decays, it gives off antimatter. But to produce the antimatter seen in the galaxy's core, you would need a lot of titanium-44. It could be created in rare energetic events. In the collision of two dead stars, white dwarfs.
A white dwarf star is a star that didn't have enough mass when it died to actually become a supernova. It just sort of cools off as a dead little cinder. But what if you have two white dwarfs that are orbiting around each other? And as they come closer and closer and collide, all of a sudden now you have enough mass to actually kick a supernova explosion off. These particular kinds of supernovae are very good at producing titanium-44. So these kinds of supernovas are very, very good at making antimatter.
These supernovas erupt in the core of the galaxy once every 2,000 years. But outside of the core, In the disk of the galaxy where our solar system orbits, these supernovas happen 3 times as often. So, the gamma ray observations were wrong. There isn't more antimatter in the heart of the galaxy. It's our region of the galaxy that contains the most antimatter. The question is, are we in danger?
If you take an ounce of matter and an ounce of antimatter and collide them, you're generating a megaton of energy, the equivalent of 1,000,000 tons of TNT exploding. So you don't need much antimatter to generate a vast amount of energy.
But the thing you have to remember is we live in this wonderful, dramatic environment of the larger universe. It's not dangerous, it's very far away from us, and it's fascinating that all of this antimatter is being produced in our galaxy. So just sit back and enjoy the fireworks.
The center of the Milky Way is violent and extreme, but things could get a whole lot worse. Rogue, supermassive black holes could be lurking near our galaxy, and they have the power to end life as we know it. The Milky Way is around 100,000 light years across, and it's home to at least 200 billion stars. But it hasn't always been this large.
We know that our Milky Way galaxy grew to the size it is now, which is huge, by eating other galaxies. And some of these galaxies would have had supermassive black holes in their centers.
When the Milky Way's gravity pulled in smaller galaxies, most of their material merged with the Milky Way. But some material, like stars, could have been slung tens of thousands of light years out of the Milky Way. This could have happened to a smaller galaxy's supermassive black hole.
It is entirely possible there are supermassive black holes wandering around out there, not in the center.
So how could it be possible that there's actually a supermassive black hole close to us wandering around, but we never even see it? Well, remember, black hole means it's really, really black. It actually absorbs radiation and any energy. So unless something is falling into a black hole or orbiting around it, you're not going to see it.
And so if this supermassive black hole were hypothetically wandering the outskirts of our galaxy, well, there's a lot less gas there for that black hole to run into. And if there's no gas around that black hole, we will not see it.
The rogue, supermassive black hole may not stay in the outskirts of the galaxy forever. Gravitational interactions slowly pull it back into the Milky Way. Billions of years later, the supermassive black hole could arrive in the center. When this rogue, supermassive black hole meets up with Sagittarius A star, the fuse is lit. The pair spiral towards each other, spinning faster and faster, reaching up to half the speed of light. Finally, the two black holes merge.
You would have an enormously energetic event on your hands. Those supermassive black holes could, in principle, merge together, create a huge blast of gravitational waves, accompanied by a profoundly energetic flash of light that could, in principle, endanger all life on Earth.
It's literally a stretching and contracting of space itself. It's like grabbing the framework of space and shaking it really hard. And if this happens in our galaxy, the amount of energy emitted, that would be bad.
When the black holes collide, they release more energy than all the stars in the galaxy combined.
Should we be panicked about this? And the answer is no. The Earth has been orbiting the sun for 4.5 billion years without any incident, right? We're pretty safe from them.
If we were around to see the two black holes collide, in the history of the galaxy.
Nowhere you want to be. It's a bad neighborhood. You've got tons of stars, tons of radiation. Stars are being born and dying. You've got the central supermassive black hole. You've got a potential swarm of black holes. You've got accretion disks. You've got flares. You've got magnetic outbursts. You've got jets. Let's just stay out here in the suburbs, all right?
Galaxy is one of the most nightmarish places in the cosmos. Incredible forces the universe has to offer. Whatever the future holds for our galaxy, the core of the Milky Way will be at the center of it all.
Our safe harbor, our island in this vast cosmic ocean. And so to understand the heart of our galaxy is to understand our home in this cosmic void.